Hey guys, it's Mr. Nakmi here. I'm bringing you a video on how to solve system of equations by substitution today. We did an earlier video on solving with graphs, and now I'm going to cover a point when, just in case you have a graph that you drew super accurate, but the point seems to be crossing at somewhere between whole numbers. Now, you could hopefully draw it as accurately as possible, but then you still might be off by a little bit. Like, you can't really tell if it's supposed to be 2.4 or 2.5. So doing it algebraically will help us to find the exact value. Okay? So this is one of two methods. The first method is substitution. What I like to do is, when I'm dealing with these types of problems, is I like to name my equations. I like to name this one equation 1 and equation 2. You can name them whatever you want, equation A, equation B, either way. And pick one of these equations and solve for a specific variable. Now, I notice a lot of students kind of just freeze up right here. It doesn't really matter which one you pick. You can pick either one, and you can pick for any variable you want, right? I'm going to go ahead and pick equation number 2, and I'm probably going to solve for y is what I'm looking at. I'm going to solve for y here. So what I like to do here is rewrite equation number 2. I have here negative 8x plus 4y equals negative 2, right? Try to get y by itself here. So I'm going to add 8x to both sides. End up with 4y equals 8x minus 2. Divide both sides by 4. Entire side over here by 4. And you end up with y is equal to 8 divided by 4 is 2x minus 2 divided by 4, which is 1/2. Now, I end up with this thing here, and this is not your answer, even though you have y equals something. This is not your answer. This is just a partial answer. You still need to find out what x is. Now, since I'm working with equation number 2, oops, that's not a 2. Since I'm working with equation number 2, I'm going to go ahead and take what I have here from equation number 2, which is y is equal to 2x minus 1, and substitute it back in to equation number 1. See, we haven't used this equation yet, right? So I just found out that y could be equal to this, and I can substitute it in for wherever I see a y in my other equation. You don't want to plug it back into the equation you just work with. That's kind of working in a circle. So plug it into the equation you haven't worked with, which is in this case equation 1, and replace the letter y, or the variable y I should say, with 2x minus 1/2. See? So here, now I'm going to go to equation number 1. I'm going to write on this side. I have here 6x plus 2, and instead of y, it's actually 2x minus 1/2. See that? What this does is it gives you a new equation. It's technically the same equation, but with only one variable now, right? You have only x's in this equation 1, as opposed to before. You couldn't solve it when you had an x and a y. So when we substitute out that y with what we have solved over here, we were able to replace it and get a new equation with only a single variable in there. So now it just becomes a multi-step equation that you guys have become pros at solving by this point, I'm hoping. So we're just going to go ahead and distribute this here, simplify it and solve it. So we end up with 6x plus 4x, what am I saying? Minus 2 times 1/2, which is 1, and this is equal to 29. Combine like terms, and you end up with 10x minus 1 equals 29. Add the 1 over to both sides. You end up with 10x equals 30. I'm running out of space here, so I'm going to scroll this down. And divide both sides by 10, and you'll end up with x equals 30. Oh, I'm sorry, x equals 3. What am I saying? Now, you're halfway done. You're halfway done. Remember, for system of equations, you're not just looking for an x value that works for both equations. You're also looking for a y value. You're looking for a point that works for both. So I have my x value. And what you're going to do with this x value is substitute this value for x equals 3 into another equation. Now, this is another part that I noticed a lot of students get stuck at. Which equation do you plug it into? And at this point, it actually doesn't matter. You could plug it back into equation number 1, original equation number 1, or original equation number 2, or heck, you could even plug it back in to this equation that we worked with earlier that's already solved for y. And I actually highly suggest that you plug it into this one, because then y is already solved for. Sometimes it's easier this way, not all cases though, but in this particular case, I suggest plugging it back into here. So you end up with y is equal to 2, and instead of x, you're going to plug in 3, because that's what we solved for earlier. So it's equal to, x is equal to 3, so I get to substitute that out. So it's 2 times 3 minus 1/2, right? And when you do this, you'll end up with y is equal to 6 minus 1/2. And when you finish this off, y is equal to 6 minus 1/2, which is about 5.5. If you want to do it using common denominators and fractions, I believe that's going to be 11 over 2. So your final answer for this problem is going to be 3, 5.5. Now, if you go ahead and graph this using a graphing calculator or Desmos, you'll see that the point that the two lines cross at is, in fact, at 3 and 5.5. I hope this is helpful for you guys, and next time we'll be covering how to solve this system using elimination, which might have been easier for this case. All right. Hope you guys have a great day. I'll see you guys later.